What if you could witness the dawn of civilization or correct a single life-altering mistake? What if you could meet your future self or prevent a global catastrophe? The desire to conquer time is one of humanity's oldest, most persistent dreams. It's a fantasy woven into our myths, our movies, and our very imagination. But is it just a fantasy? For over a century, this dream has been colliding with the hard, cold laws of physics. What was once the realm of mystics and storytellers is now a serious, if speculative, field of scientific inquiry. So, we are left with the ultimate question. Is time travel possible? We are all time travelers. From the moment we are born, we are carried on an irreversible one-way journey into the future. We measure our lives in seconds, hours, years. We are prisoners of the clock, subjects to the tyrant we call time. Our entire civilization is built around measuring and managing time. But what is it? For millennia, philosophers like Aristotle and Newton saw time as an absolute river, flowing at the same rate for everyone, everywhere. A universal clock ticking in the background of the cosmos. But in the early 20th century, a young patent clerk in Switzerland shattered that comforting notion. His name was Albert Einstein. With his theories of relativity, Einstein revealed that time is not a rigid, universal constant. It is fluid. It is malleable. It is a dimension, interwoven with the three dimensions of space into a single fabric, space-time. And this fabric can be warped, stretched, and twisted. This single, profound insight didn't just change our understanding of the universe. It opened the door, just a crack, to the possibility of time travel. Welcome to the weird and wonderful world of relativistic time travel. Forget plutonium and flux capacitors for a moment. The first and most important thing to understand is that time travel to the future isn't just possible, it's a proven fact. We're all doing it right now. The trick is learning how to do it faster. Let's take the classic twin paradox. One twin blasts off on a spaceship traveling at 90% the speed of light. That's 670 million miles per hour on a 5-year round trip. For her, 5 years pass. She reads books, exercises, ages 5 years. But when she returns to Earth, she finds her twin brother has aged 15 years. For him, 15 years have passed. She has effectively traveled 10 years into his future. This isn't science fiction. This is special relativity. This phenomenon, called time dilation, has been experimentally verified. Not with spaceships, but with particles. But speed is only one way to manipulate time. Gravity, as Einstein taught us in his general theory of relativity, is the other. The stronger the gravity, the slower time passes. Your head ages faster than your feet, though by an infinitesimally small amount. But on a cosmic scale, the effect is dramatic. If you could stand on the surface of a neutron star, time would slow down so much that you could watch the entire future history of the universe unfold in what felt like a single lifetime. We rely on this principle every day. The GPS in your phone has to account for time dilation. The satellites are in a weaker gravitational field and moving at high speed relative to us on the surface. Their clocks run faster by about 38 microseconds per day. Without correcting for Einstein's theories, your GPS would be off by several miles within minutes. So, we can travel to the future. We're doing it slowly right now, and we know how to do it faster. But what about the past? That's where the science gets truly strange. If traveling to the future is a one-way street, traveling to the past is like trying to build a bridge back to a city you've already left. The most famous proposed bridge is the wormhole. First theorized by Einstein and Nathan Rosen in 1935, a wormhole, or Einstein-Rosen bridge, is a shortcut through space-time. Imagine the universe as a piece of paper. A wormhole would be a fold that connects two distant points, allowing you to bypass the long journey across the surface. But here's the catch. The kind of wormholes predicted by general relativity are incredibly unstable. They would snap shut in an instant, far too quickly for even a single photon of light to pass through. To hold it open, you would need a form of matter with negative energy density, something that gravitationally repels rather than attracts. We call this exotic matter. Does exotic matter exist? In a quantum sense, yes. The Casimir effect demonstrates negative energy densities in a lab, but the amounts are vanishingly small. To stabilize a wormhole large enough for a person, you would need a Jupiter's mass worth of exotic matter, a clear engineering impossibility with our current understanding. But wormholes aren't the only theoretical ticket to the past. Another involves cosmic strings, hypothetical, infinitely long, and unimaginably thin defects in the fabric of space-time left over from the Big Bang. In the 1990s, physicist J. Richard Gott proposed that if two such cosmic strings were to fly past each other at near light speed, the extreme warping of spacetime around them could create a closed time-like curve, a path through spacetime that loops back on itself. It's a mind-bending concept, but like wormholes, it rests on entities we have not yet proven to exist. The science of pastward time travel is, for now, a science of magnificent, tantalizing ifs. Even if the physics one day allows it, would the logic of the universe permit it? The most famous logical barrier is the grandfather paradox. If you were to go back in time and kill your own grandfather before he met your grandmother, you would prevent your own birth. But if you were never born, you could never have gone back in time to commit the murder. It's a logical inconsistency, a contradiction that many physicists believe is forbidden by the laws of the universe. The grandfather paradox isn't really about grandfathers. It's about causality, the principle that cause must precede effect. Our entire understanding of reality, from why a dropped glass breaks to the principles of justice, is built on this foundation. Time travel to the past shatters that foundation. It allows an effect, your non-existence, to eliminate its own cause. But quantum mechanics offers a potential escape clause. The Novikov self-consistency principle, proposed by Russian physicist Igor Novikov, states that any actions taken by a time traveler were always part of history. You would simply be fulfilling events, not changing them. You would fail to kill your grandfather, perhaps in a comically improbable series of events. Then there's the many worlds interpretation of quantum mechanics. This is perhaps the most radical solution. It suggests that every quantum decision spawns a new branching universe. So, if you travel back in time and kill your grandfather, you don't create a paradox. You simply branch off into a new parallel timeline where you were never born. The original timeline, where you came from, remains untouched. But is that really time travel, or is it simply universe hopping? You haven't changed your past, you've just arrived in a different version of history. The philosophical implications are staggering. It suggests an infinite multiverse where every possible reality exists. Whether through consistent loops or branching realities, the universe may have its own ways of preventing paradoxes, making the logic of time travel as complex and mysterious as the physics. The dream of time travel is not new. Long before Einstein, humanity was fascinated by the idea. In Hindu mythology, the Mahabharata tells of King Kakudmi who visits the heavens for a short while, only to return to Earth to find 108 yugas, millions of years have passed. The Japanese legend of Urashima Taro involves a fisherman who rescues a turtle and is taken to an undersea palace, returning after 3 days to find 300 years have passed on land. These are early tales of time dilation, of traveling to the future. But the concept of a machine for traversing time is a more modern invention. H.G. Wells' 1895 novel, The Time Machine, was a watershed moment. In an age of unprecedented technological progress, Wells imagined time as the fourth dimension and built a vehicle to navigate it. His vision was less about magic and more about engineering, reflecting the spirit of his age. Since Wells, the concept has exploded, evolving with our scientific understanding. From the cosmic visions of Arthur C. Clarke to the psychological puzzles of Kurt Vonnegut's Slaughterhouse-Five, time travel has become a versatile tool for exploring history, destiny, and the human condition. If science provides the equations, popular culture provides the dreams. Time travel has become one of the most powerful and enduring narrative engines in modern storytelling. Back to the Future gave us the butterfly effect for the masses. A single, small change in the past, Marty interfering with his parents' meeting, has catastrophic, ripple-like consequences for the future. It's a narrative of cause and effect, of history as a fragile, delicate thing. The Terminator presents a darker vision, the causal loop. Kyle Reese is sent back to protect Sarah Connor, fathers her child, John, who will one day send him back. The future is not changed. It is created by the very attempt to change it. A perfect, self-consistent, and terrifying loop. Doctor Who introduces the idea of timey-wimey ball, time as a complex, non-linear web of events. The Doctor is less a time traveler and more a time tourist, witnessing fixed points and mutable moments, often more concerned with preserving history than changing it. And Avengers Endgame gave us a crash course in the many worlds theory, where Back to the Future is a fantasy, and every trip to the past creates a new branching timeline. These stories do more than entertain. They are a playground for our deepest anxieties and hopes. They allow us to ask, if I could change one thing, what would it be? And what would be the unintended cost? For all the compelling theories and captivating stories, many physicists believe that a universal censor will always prevent time travel in practice. The late, great Stephen Hawking proposed the chronology protection conjecture. He quipped, "If time travel is possible, where are the tourists from the future?" His conjecture suggests that the laws of physics conspire to prevent closed time-like curves from forming, to make the universe safe for historians. One proposed mechanism is that the moment you try to create a time machine, say by focusing immense energy to twist space-time into a loop, you would trigger a runaway feedback of virtual particles. The energy would become infinite, or a black hole would form, destroying the wormhole or the loop before it could be used. Then there's the sheer energy requirement. To warp space-time on a human scale requires energies on the scale of a star, or the manipulation of objects like cosmic strings, which are beyond any conceivable technology. The universe is old, vast, and largely empty. The sheer distances and energies involved in cosmic engineering make the task seem, for now, hopelessly out of reach. Time travel may not be forbidden by the laws of physics, but it might be forbidden by practical reality. So, after this long journey through the science, the philosophy, and the stories, are we any closer to an answer? Can we build a time machine? The honest answer is, we don't know. Travel to the future is definitively possible. Travel to the past remains a glorious, magnificent mystery, hovering at the very edge of theoretical physics. But perhaps the true value of the time travel question isn't in the answer, but in the journey of asking it. The quest to understand time travel forces us to probe the deepest mysteries of the universe, the nature of time itself, the fabric of space-time, the relationship between quantum mechanics and gravity. It pushes our mathematics to its limits and our imaginations to their breaking point. We are time travelers on a one-way journey. We cannot go back and change the past. We cannot rush headlong into the future. We have only this moment, the ever-elusive now. And in this moment, we have the incredible power to ask what if, to dream of other times, other possibilities, to use our brief slice of eternity to try to understand the cosmos of which we are a part. The dream of time travel is ultimately a dream of connection, a desire to reach beyond the limits of our own lifespan and touch history, to shape destiny, to understand our place in the vast river of time. And in that sense, perhaps we are all time travelers. We carry the past within us, in our genes, our memories, our stories. And we are all together hurtling towards a future we are destined to create.